So, hi everybody. So, my name is Paul, and we are a little bit late, so I'm gonna avoid the bio stuff. I will make this presentation with a colleague of me. He should be here today, but in fact he has a calendar conflict, so he's in Dubai, and it's not easy to be in two places in the same day. So today I'm gonna speak about a new kind of issue we have during investigation. It's in fact a new trend for APT actors to add some feature inside of the infection vector in order to never deliver the exploit or the final remote administration tool if they are not sure at 100% that the targeted people is a good one. I will show you with 5 case studies exactly how the guys modified the infection vector in order to limit the spread of the exploit of the or the remote administration tool. After I will mention that it's maybe the beginning of a real massive trend, and I will explain you some other tricks that attackers could do to detect if it's really the good target and not an analyst or a sandbox or whatever. I will speak a little bit about mitigation. It will be something really common. It's not rocket ship, it's simply best practice. It's going to be short. After I will have a conclusion, and I decided last week to add a post-conclusion chapter about technical stuff and about PowerShell, just as before, and WinDBG. So I will show you how to debug PowerShell with WinDBG and specifically how to massively make automate analysis with this tool. So, what's new? So, in my case, generally, the common model is the attackers send a document, an Office document, Excel document, whatever, with macro or a 0-day or vulnerability, and they finally execute something on the machine. And this something is usually a remote administration tool that gives access to the bad guys to the machine. So, but the thing is, 0-day are expensive, first, and if you develop your own remote administration tool with complex feature, etc., it's expensive too. So we are seeing a new trend where attackers try to never deliver 0-day exploit or rat on infected machine if they are not sure at 100% is the good target, is the good person on the system. The first case study I had to work on concerned NATO, and you've got the hash if you want to look at it for yourself, by yourself. It's a Word document, and inside of this Word document you have a Flash object. You can embed it Flash object in Word document. It's supported without any problem. And this Flash document did something not really common. In fact, he used a Flash API named capability server strings to generate a kind of HTTP request with information on the system. So, for example, you have the Flash in ActiveX object. It means that if you extract the Flash object from the document and you execute it in standalone, typically when you are an analyst, you take sub-object and you work individually on each sub-object. If you use the Flash object alone, this value won't be ActiveX, like on the screenshot, but standalone or something like that. So this query is sent to the CC, and the attacker is able to check the value and be sure that the Flash object is executed inside of a Word and not directly like a Flash document. Other thing, the attackers get the Flash version. So he's able to provide an exploit that matches perfectly the Flash version of the target. And last thing, the Windows version. So he can have an exploit that match exactly the Windows version. So this flash object, the first step of this flash object is simply to send data on the infected machine. If the data is correct for the bad guys, at this time you will receive a second flash object, and this one will be loaded in memory, and this one contains the exploit used to drop the final malware on the machine and execute it. So if you don't have a good data, you won't have the final payload. And in this case, the attackers was fine with us because his name is variable with shellcode, with exploit, etc. So it was easy to guess the purpose. Yeah, it's on-the-fly flash loading. Something interesting is the attackers sent the first email with the malicious attachment at the end of December, just before the New Year. And here is our OpenDNS extract of connection to the CC. And you've got some pic at the beginning. And on the right, the huge mountain, is when security researchers finally found the document and work on it. So it generates a lot of requests to the CC. And obviously, more or less, everybody was in holiday during this period. Another case study that matches the same way of work is from a different actor. So it's not a specific actor that tried to avoid giving zero day to security company. They use a document too, where the title contains the name of the ambassador secretary of, I don't know, remember which country, Lebanon. So I don't know if the profile is a real one on LinkedIn. She doesn't have a lot of friends extra, so I think it's maybe a fake profile to justify the title of the document. I don't know. So in this case, it's an Office document with VBA inside. And the purpose of the macro is to, the first step was to decode in base64 a string. And this string was stored on a JavaScript file on your machine. And at the end, it executes the JavaScript file with a key, ERC4 key. So if you find, for example, the JavaScript on VirusTotal, or if you find the JavaScript on a machine, if you don't have the key put in argument when this JavaScript is executed, you cannot read the content. It will be encrypted. So you need the initial Office document to be able to analyze the JavaScript. And the purpose was really simple. Take this key and decrypt a second JavaScript script. And the purpose of this final script was to get a lot of information on the machine. So you get the system info output, so install patch and your configuration basically. He upload the network configuration, the share configuration, the users, etc., etc. So all these data are sent to the attackers, and at this moment, only if it matches what the attackers want, you will receive the final payload on the machine. If it doesn't match what the attackers want, the final payload is never downloaded, and you cannot continue your investigation. It's finished for you. Another case study with the same approach is an Excel document with VBA. In this case, the document creates a PowerShell script and executes the script with inside of a scheduled task. So it's not directly a create process, but it creates a scheduled task. And same thing. This dropped file, PowerShell script, connect to a CC and send specific information on the machine. If it doesn't match what the attacker is expected, no final payload. And your investigation is finished. I work a lot of South Korean threat, and one specific actors in South Korea started to do exactly the same things few weeks, months ago. In South Korea, they basically don't use Office. They use Hangul, which is a local Office-like application that supports Korean characters, in fact. So the extension of this kind of document is that HWP for Hangul word processor, something like that. So I started to analyze a lot of HWP document, and I find this one. It's pretty interesting. And if you look at the logo at the bottom of the first page, it's the logo of the Ministry of Unification. So it's a ministry where the purpose is to unify North Korea and South Korea. So it's something really official, something fun. I don't speak Korean. And I sent the document to someone in South Korea to have a translation of the document. And the guy was so afraid. He said to me, I think it's a classified document. I cannot read it. I will have some problem, blah, 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 blah. So visibly, it looks really legit for people. So how works the HWP format? In fact, it's a little bit like an Office document. It contains OLE object, and the difference is each object are Z compressed with zlib. So you can simply extract object, unzip, and zlib the object, and you have the final document. In this case, something interesting is the payload was not executed automatically when you open the document. When you open the document, you have two links, in blue in my screenshot, to have additional information. And if you click on the link, you will have additional information, and in fact, it executes the payload on the machine. So if you execute this document on a sandbox in Korean with Hangul installed, you must click on the link to have a full report of what's happened on the machine. So here it's the output of my sandbox. And when you click on the link, it opens a new HWP document, and behind execute the shellcode. This document is a decoy document to make legit. I have more information about the document. What the payload does in background, he gets the computer name, he gets the username of the machine, the execution path, and the BIOS model. And he used a really specific key, registry key, to have the BIOS model. And you can make some search on Google, and it was not really documented. And I don't see a lot of malware that take this specific key. So it's interesting. What is the purpose? Always the same. Identify the target and be sure it's the real target. Here is the pcap of the exfiltration of this data from VirusTotal. On VirusTotal, you can download sample, and sometimes you can download the pcap generated by the sample. And once decoded, you have the information. And typically, Tequila Boom Boom is the host name of the sandbox system of VirusTotal. Janet is the name, the username of the sandbox of VirusTotal. VirusTotal put the sample in C drive and execute it with a hash. And finally, you've got the BIOS model. It's Innotech VirtualBox. So VirusTotal uses VirtualBox. So typically in this case, when it's executed by sandbox of VirusTotal, the bad guy received this report, and they're sure it's not the real target, and they will not provide the final payload. The final payload is generated dynamically. If you look here, the first data is an ID, and it generates an ID underscore put.jpg, and in fact, it's a final remote administration tool. In this case, we sadly didn't get the final the final binary. And the attackers compromised the Korean government website to store the executable generated dynamically if the infected target match what the attackers want. So basically, you cannot blacklist legitimate governmental website in your country. Yeah, here it's the map. I will share the slide, and you can have more detail about the infrastructure of the bad guy. Always concerning South Korea, as I said on the previous case, we were not able to have the final remote administration tool, so investigation finished. But on another case, we finally find a way to have it. And in this case, the attackers compromised the official email of Korean Global Forum, so it's a forum in South Korea. So bad guys compromise the email account and send spear phishing from this legitimate email to several people with a survey in attachment. HWP file. It's South Korea, it's always HWP file. And they use another kind of email asking for help for someone living in North Korea. So in this case, the attacker is trying to work on empathy on the target. The two documents, and it's same things. It's OLE object inside of the HWP document, ZLib compress, as I said. And in this case, it was an exploit that downloaded a JPEG file. So it's a pattern for this group. They always download JPEG file. Maybe this group is a previous speaker, I don't know. And in this case, we were able to download the final payload, and it was a funny sample. I'm going to speak really quickly about it because it's not so common. The first thing, it does not support Windows XP. If it's run on Windows XP, you have an infinite loop. So your sandbox system shows nothing. He is looking for several running analyst tools. It's really common for malware. And if he identifies one of these tools, if, for example, you have a VirtualBox or you have a Process Explorer or this kind of application, the malware will download a movie, a TV show on the internet. That's all. So if you look on your logs, you will see you are watching a TV show, a Japanese TV show. If you are correct and not a sandbox, he makes some connection on the first CC. It was 7 Twitter account. So he's trying to connect on this Twitter account through the API to download order. If it doesn't work, he used Yandex, Russian cloud system, with 4 different accounts. And if it really don't work, he switched to Mediafire cloud platform with account. All the accounts are coded inside of the sample, so you can see if it's up and running or not. And additionally, he contains kilobits. It's something really common. So, on each of these case studies, we saw it's basically always users opening document, and it's basically always start by phishing campaign, but they make a lot of efforts to keep their exploit and tools private. So for us, it's a little bit boring because sometimes you spend time on investigation and it's finished. You cannot go deeper and you cannot have the final tool, or you don't have the 0 days, that no patch, etc. And maybe it's the beginning, because we work on several other cases, absolutely not linked to targeted attack, but more crimeware stuff. And sometimes people from crimeware have a pretty nice idea. For example, we saw a group that dropped Pony Stealer malware using Publisher. I say, what the fuck? Why they use Publisher to drop this kind of stuff? And in fact, Microsoft documented, I think, why. The protected view mode is not supported by Publisher. So if in your company you put a GPO that block macro and the user cannot enable macro, in fact it works for every Office product except Publisher. And Publisher is installed by default in Office 365. So if you are people we have this kind of Office, automatically have Publisher installed on the system. So I think it's the reason why they decided to use Publisher to drop Pony. I add another slide because each time I'm at conference, people say to me, yeah, I use macOS, I'm safe and saved. So I decided to add a slide to prove they're wrong. We worked on Office documents, so you can have Office on Mac, it works. And macro are supported on macOS. It works too. So I work on a case where the guy have a function named MacShell and execute a one-liner Python script on a Mac. So you have exactly the same problem on macOS. If you have Office, you can enable macro and you can execute Python script on your system. So macOS is not kind of protection. We have some mitigations for this topic. It's nothing awesome. It's simply a good practice, like disabling macro execution. On Windows, on Office 2016, you can have a better control of macro. For PowerShell, typically you can add some execution restriction policy. So all this stuff are documented and should be applied. And if you apply all this stuff, all the case study I mentioned won't work anymore. You can disable, definitely, JavaScript and WScript. Generally, it does not generate problem, except if your company developed everything in JavaScript. So in this case, good luck. And more generally, update your system. As you look on Friday last week, install AppLocker and configure it correctly. I see a lot of cases where people install AppLocker but does not include DLL protection. So it avoids the execution of .exe file, but it does not block library loading. So yeah, and after you got more advanced stuff like device guard or VBS on Windows 10. I'm not here to mention everything. And for macOS, I don't know if we can control script, and I don't think we have all the mitigation equivalent of Windows system. So the conclusion for me is the actor might put a lot of efforts to protect the valuable code, and something interesting is generally if the actors already compromise your company, they know your network better than you. They know your IP range. They know your domain. They know the pattern of your username. They know the pattern of the host name. So if the attackers was already on your infrastructure in the past, he can really easily check if it's on the correct machine. And I'm not sure that your sandbox system has bind to your domain. I'm not sure the naming convention of the users inside of the virtual machine match your naming convention. Same for the host name, same for everything. And as the guy was here before, he can easily control and check if it's a real system. Scripting language are really trendy. Each case, the guy use PowerShell or JavaScript or batch files sometimes. So we must really take time to have a control and an audit of this script execution. It's really important. And all these language are embedded in Windows. You don't have to install anything. It's here. Why don't use it? And sometimes it's a little bit obfuscation is by default. If you look at PowerShell, sometimes it looks like obfuscated by design. So take time to read it. Yeah, it's exactly what I said just before. The bad guys know your infrastructure sometimes more than you, so it's easy for him to check, I think. Yeah, so have you got some question concerning this first part before going to the next one? We have some time for that, don't worry. No? I was clear? Or boring? You are sleeping? Yeah. So, I compressed a little bit the first part to add something not scheduled at the beginning. I decided last week to add it. It's a technical bonus, because technical conference, so I was a little bit frustrated to don't put any assembly language in my slides, so I decided to add a post-conclusion part. Last week, I opened a poll on Twitter, and I asked a simple question. I would like to know if I was the only one to use WinDBG to analyze PowerShell script. And I will try on the room. So who say yes? I'm the only one to use. Who said no? So everybody is what the fuck. Okay. I will explain you why. So, PowerShell is more and more often used by malware developers, and I have more and more to analyze this shitty language. So I need to find a solution to have a better life. And I like WinDBG because it works, it's here, it's free, it's efficient. So I would like to analyze PowerShell script with WinDBG. So, yes, you can. Just for people that don't know WinDBG, it's a Reddit schema to clearly understand where we are. So, in fact, you have two different kind of usage of WinDBG by malware developers. Sometimes they directly use unmanaged code, so like DLL import in C#. So they can directly use, I don't know, virtualalloc API. And in this case, you don't have to make something really specific. You debug as usual. You make some breakpoint on virtualalloc, and you can debug it like every application. So this part is not the most interesting part. But sometimes the guy use directly PowerShell command. And in this case, you cannot debug as usual. How PowerShell works, in fact, each time he tried to execute PowerShell command, in fact, behind it used .NET framework. So PowerShell is more or less .NET. So WinDBG has the .NET support. You can make load by SOS CLR. And after you've got new commands, for example, BPMD for breakpoint manage, I don't know what. And in this case, you can directly breakpoint on .NET execution. So here it's an example where I breakpoint on process.start. And as it's high-level language, you can have several functions for process start. The same API. In fact, you have several functions depending on the type of argument you put. If you use a byte array, if you use a string, if you use something else, it will be a different function. So that's why in this case I've got 5 different breakpoints by setting only one. So first thing, I'm able to breakpoint here. So next step, I execute my PowerShell, and it stops the execution on my breakpoint. WinDBG provides a command to analyze the stack of the .NET code. It's a CLR stack, for example. And here we can see that one parameter is start info structures at a specific address, finishing by 18. I can have information on these structures finishing by 18, and I've got all the description of what is a process start info object. And the first field of this object is a file name, and it's a system.string structure. So I can dump directly these structures, and I can see it, in my case, notepad.exe. So I can basically use WinDBG to automatically get the first argument of start-process. It works. if you want to avoid all the manage command, I give you directly the register used to store this value. Just for information, in this case is RCX, but it depends if you are PowerShell in 32 or 64 bits, and it depends of your .NET version. In .NET 2 and 3, it's different from .NET 4, so you need to check when you analyze something. Another example is I've got a lot of malware that make a download a file and execute it after. I can do exactly the same thing. I can breakpoint on system.net.webclient.load file. I got my breakpoint, and yeah, it's stopped on breakpoint, and I'm able to get the two arguments. The first one is the URL, and the second one is where the file will be stored on your system. So the good point for me is, imagine I've got to analyze, I don't know, 600 PowerShell script, but I know it's the same kind of stuff. It's obfuscation, encryption, XOR, base64, whatever, and at the end, he performs a download file and a start process. It's all different script, but the philosophy behind is exactly the same. I decrypt the URL, I download, I execute. In this case, I can easily create a script on WinDBG to pass my 600 PowerShell script in 1 hour. It works. I can show you. Because I'm crazy, I decided to create a demo a few minutes ago. So, if I make my start process here, so my calculator is executed, but here you can see I directly get the argument. Maybe it's small, I don't know if I can increase, but I directly have the executed command. And if I do the same thing with downloading, for example, I download the homepage of NorthSec, I store it in test.txt file. Yeah, same thing. I automatically get the URL and automatically get where it's stored on the system. So I can really, really easily create a script to massively dump argument of this API and automatically analyze, get URL, blacklist URL, etc., etc. So it works. So the last slide for me. So generally people doesn't like WinDBG for really good reason, and but it's really powerful and you can make really awesome stuff. You can even debug .NET code. For example, I often use it to create unpacker for .NET packer. So directly in WinDBG, I'm able to manipulate .NET to unpack and get the final payload, the final P file, the final shellcode, the final whatever. And I use WinDBG to do that because it's perfectly support .NET and you can make script. You can make script with the shitty language of Microsoft. I don't know if you know how it works. It's so beautiful, I must show you. Yeah, it's a script. So it's not really easy, but you can have an extension to have Python support, so you can write it in Python if you prefer and don't like this wonderful syntax. So you can really make some powerful investigation and give your life, have a better life and make a lot of stuff automatically. So if you have questions, the first part or the second part, I'm here and I will stay here all the day. So if you don't want to speak in front of everybody, feel free to come to me after.